This video is going to be about measures of dispersion. So this is analyzing how spread out a data set is. So there's two things that we're going to look at for this. One is range and one is standard deviation. The range is very straightforward. It's just the difference between the biggest number and the smallest number. That's it. That's all range is. Standard deviation is a bit more complicated. So standard deviation describes kind of the typical distance or difference or deviation between a specific data point and the mean. We use the Greek letter sigma, which is this one right here, kind of like an O with a little thing sticking off the side. We use that to describe or to denote standard deviation. Now, if we have a data set with, say, n numbers in it, we could call that x1, x2, so we've got 2 data points, 3, 4, 5, however many up to the last one, which we'll call the nth data point. And to get the standard deviation, what we're going to do is use this formula here. So the standard deviation, sigma, is equal to the square root, and then we're going to take the first x value, the first whatever data point, and subtract x bar. Remember that x bar is the average or the mean. So we're going to find that we have to find the mean first. We find the mean of all the data points, and then that's what we use here. So we take the first data point, subtract the mean, and then square it. Then take the second data point, subtract the mean and square it. Third data point, subtract the mean, square it, all the way up to the last data point, subtract the mean and then square it. Add all of those together, divide by how many data points there are, and then take the square root. So let's work through an example here. Alright, so we've got a data set here. We're competing in an air hockey tournament. The winning scores for the first 10 games are as follows: 14, 15, 17, 17, 11, 15, 13, 12, 15, and 13. It says find the range and standard deviation of this data set. Well, the range is fairly straightforward. Again, so we just find the biggest data point and the smallest data point and then subtract them. So the biggest data point is 17, smallest data point is 11. Subtract those and we get 6. So the range is 6. Then for the standard deviation, well, first of all, we need to know the average and also how many things are in the data set. So there are 10 things in this data set, so that's n in this formula. And then the average, in this video, I'm going to assume that you already know how to calculate average since we did that in the last video. So the average of this data set, x bar, is 14. So that's what we're going to use when we're calculating standard deviation. So let's start calculating. So standard deviation is equal to the square root, and I'm going to leave that like that for now so that I can draw it once I've got all the data written out here. So we're going to take the first data point, and I'm just going to do these in order. So the smallest one is 11, then minus the average, which is 14, and then square it. Add to that the next biggest data point, which is 12, subtract the average and then square it. Then 13 minus the average, square it. 14 minus the average and square it. Then 15 minus the average, square it. And do that a couple more times because we've got several 15s. And then all the way up to the last one, which is 17. I realize I ran off the screen there, so all the way up to 17, and then square it. Then divide all of that by the number of data points that we have, that's 10, and then again take the square root of all of that. Alright, so then sigma is equal to, if we simplify this, what we're going to get is, well, 11 minus 14, that's negative 3, square that, we get 9, and then I'm going to assume that you can calculate all of those. And so this is what you would get. Oops, that should be a plus 1, plus 1. See, there's 4 of those from the 4 15s, because 15 minus 14 would be 1. And then 9 at the end, all over 10, square root all of that. And then on the top, if we add all of that together, we get 28 over 10, and then we have the square root. So this is 28 divided by 10 would be 2.8. The square root of 2.8 is approximately 1.67. So the standard deviation is 1.67, approximately. Now, what this standard deviation means, and we're not going to go too in depth into this, but basically what this means is that well over half of the data is within one standard deviation of the mean of the average. So that means that about 60% of the data falls within 1.67 to the left or right of the average. About 95% of the data would fit within 2 standard deviations of the mean. So multiply this by 2, we get about 3.35. So if you go 3.35 to the left of the average and 3.35 to the right of the average, that would cover about 95% of the data points. And if you go 3 standard deviations, that's about 5.02. I think it's like 99.7% or something. Almost all of the data fits within 3 standard deviations away from the mean.